Okay, I've got 0.6 plus 0.4 times by 1.2. This is the summer 85.1 homework. And I need to think about my BIDMAS rules. So this is the first area where somebody could go wrong by not applying BIDMAS. I need to do the multiplication before I do that addition. So I'm going to do 0.4 times by 1.2. Now to do that multiplication, the method which I'd like you to use is not the column method, because you'll get it wrong with where the decimals go. Instead, it's just to do 4 times by 12, and that gives you 48. But in the whole original calculation, there are 2 numbers after the decimal point. What that means is that this one was times by 10 and this one was times by 10. So my answer has to be divided by 10 and then divided by 10 again, or divided by 100. So my answer is 0.48. So I've got this 0.48. I know that that's correct because it can't possibly be 4.8 because it's less than 1 times by about 1. So it can't suddenly become 4 or anything like that. So I then have to do the rest of the calculation. So 0.6 plus 0.48 equals 1, right? Because 0.6 plus 0.4 would be 1.08. So this is a couple of skills coming together in this. In this one, yes, you do have to apply BIDMAS, but reality that's going to work left to right anyway. So 5 times by 0.8. Well, if I do 5 times 8, that gives me 40. But then that 0.8 is being multiplied by 10. So 5 times 0.8 is just 4. I have to divide that by 10. So I've got 4, take away 1.7. So that gives me 2.3. Question 3. We've just started looking at ratio. So this should, if you did this before we started looking at it, and you got it wrong, perhaps you can already see what you need to do. But what I'm going to do is just make that 1. So in order to do that, using my equivalent ratios, I'm going to divide by 5. I'm going to divide 35 by 5, gives me 7. So 1 to 7. Question 4. Right, so this is working the other way. So if I think about 1 to 15, and then it goes up to 4 here, using equivalent ratios, that's been multiplied by 4. This would be multiplied by 4. That's going to give me 4 to 60. So it works just the same way as equivalent fractions work. Question 5. 5x plus 3 equals 3x minus 3. We're solving equations, unknowns on both sides. Firstly, you can do this either way round, but I would do this to get the x's all on one side. So that gives me 2x plus 5 equals minus 3. Then I'm going to take away 5 from both sides. This is the working out I'd like to see, guys, clearly set out like this. 2x equals minus 8. So then if I divide so if I've got 2x equals minus 8, I've just rewritten that, and I divide by 2 both sides, I'm going to get what x is equal to, which is 4. Or 4 minus 4. Question 6. Same sort of deal. Again, I would tend to work with the x's first, so I'm going to add 4x to both sides because this side has minus 4x, so I'm going to add that 4x to both sides. Gives me 10x minus 9 equals 51. Add the 9 to both sides. That gives me 10x equals 60. And then divide both sides by 10. That gives me 1x is 6. Right, question 7. This stuff on graphs, I don't think you guys have done that much on it, but this is how it works. We know that coordinates are the x amount and the y amount, the x coordinate and the y coordinate. So with this, if I put 4 in as part of the x, this should produce 4 over here. That would make this lie on the same coordinate. So I'm going to substitute that in there, the x coordinate in there, and see what we get. So 2 times by 4 minus 4. And so if this is equal to 4, then it works, because then y would be equal to it. So y equals 2 times 4 minus 4. So y is equal to 8 minus 4. So y is equal to 4. So does it lie on the line? Yes, it does, because when I substitute the x-coordinate in, it produces a y-coordinate of 4. When I substitute that in there, it produces that there. So the answer is yes. Let's remember to answer the question. Question 8. Same thing. This is the x-coordinate. This is the y-coordinate. I take my x-coordinate and substitute it in here. So I get y equals 19 plus 3 times by 3. And does that work? Let's check it. Y equals 19 plus 9, which is equal to 28. Does it lie on the line? It does, because that matches that one. The y coordinate is 28 when the x coordinate is 3. So my answer again is yes. It's just been pointed out, which is absolutely a fair way, that you could substitute in the x-coordinate and produce the y, or you could substitute in the y-coordinate and check that the x-coordinate would come out as 4, or in this case, or as 3 in this case. As long as it works, as long as you substitute one in and check the other against it, then that's fine, that's good working out. So this is the level of working out which I'm looking for in all of these questions. Right, next one is, I probably don't need to see that much working out for. All I've got is a linear sequence, which is going up 2 each time. So this is just 2n. There's nothing else to this, because it's going up 2 each time. 2 times n. Remember, n is the term number. So n is like, goes 1, 2, 3, 4, and so on. So the first term is just 2 times 1, 2. The second term, 2 times 2, 4, and so on. Now this one is a bit more tricky. It's going down 6 each time. Again, it's a linear sequence. So remember what the term number is. So the term number goes 1, 2, 3, 4. It just means the first term, the second term in the sequence, the third term in the sequence, the fourth term in the sequence. So my nth term is minus 6n. Now, for the first one, that would give me minus 6 times 1, which is minus 6. I need to change it by adding something on to make it up to 0. So I need to, in this case, add 6 on. So I've got minus 6n plus 6. This would also be the same as 6 minus 6n, but normally we would write it in this format here. Okay, gradient of lines. I know, again, this is something you guys are not too sure about. Not really covered it very much. So just a quick note on what you guys have at least heard about, which is that the gradient is this one here, the coefficient of x. Now that says m, it's any number, okay? Any number there gives you the gradient. Now we don't have it in that format yet, so we need to rearrange, we need to change this equation so that it looks more like this. We need 1y there. And the only way to do that is to divide both sides by 2. If I divide that by 2, I need to divide this side by 2. So what I have here is y equals minus 6 divided by 2 is minus 3x. And plus 1 divided by 2 is plus a half. So my gradient is the coefficient of the x. It's this number just before the x here, which is minus 3. Right, question 11 was talking about the gradient. Question 12 is talking about the y-intercept. So the y-intercept here is whatever number is just there. Okay, this is the y-intercept. It's where it crosses the y-axis, where a graph crosses the y-axis. For example, there would be the y-intercept. So what I'm going to do is I'm going to just rearrange this into this correct form here. So I'm going to divide both sides by 3. So that gives me y equals, right, 12x divided by 3 would give me 4x. So my gradient here would be 4. And 15 divided by 3 would give me 5. The y-intercept is this part here, so the y-intercept is 5. Okay, 16 out of 40 is a percentage. So this one is that slightly trickier one, because what we're going to do is not go straight at the 100, although you could figure out, you could go straight for 100 by multiplying by 2.5. but it's probably going to be easier just to divide both sides by 4. That gives you an amount out of 10. So because 4 is a common factor, I can just figure out that that's the same as 4/10, which is the same as 40/100. So that is just 40%. And 85 out of 200. Now, I could divide by 2 to get it out of 100, or I could multiply it by 5 to get it out of 1,000. So either of those ways would work. What I'm going to do is just half it, because a percentage is always out of 100. So I'm just going to divide that by 2. So I need to divide this by 2. Now 85 divided by 2 would give me 42.5. So it's 42.5%. 2 3/4 plus 2 1/3. A few different ways of doing this. Probably the easiest way is to convert both to improper fractions. This is something that you would have been drilled heavily on in primary school. So we got 8, 9, 10, 11 quarters plus 6, 7/3. That's going to be the same as, right, I need a common denominator, in this case 12. So 4 times by 3 gives me 12, 11 times by 3 gives me 33, 3 times by 4 gives me 12, so 7 times by 4 is going to give me 28. So then I'm going to add those together, 33 plus 28, 33, 43, 53, 63, 61 twelfths. This is one method. There are other ways of working this out, but this one is the one people tend to learn, convert them both to improper fractions. So 61 over 12. Now how many 12s go into 60? 1, 5 do, because 12 times 5 is 60, and I've got 1/12 left. My answer is 5 1/12. Multiplication is quite a bit easier. I've just got 22/7 converting to an improper fraction, and I'm going to multiply that by 5 halves. So that's going to give me 22 times by 5 is 110, and 7 times by 2 is 14. Right, how many 14s go into 110? I need to think about 14, 28. Is it 7? So 7 lots of 14 would be 108. So I've got 2 14s left. 7 1/7 when I simplify it. Right, guys, error here. It's not 7 2/14. I did 7 times 14 quickly in my head, and I got to the wrong answer. It should give you 98, doesn't it? Not 108. So if it's 98, that would be 7 12/14, which would give you 7 6/7. Question 17. Round 39 to one significant figure, 40. So all that you're doing with these rounding to significant figures is which is the most important column there. The most important column is the tens column. If you change the tens column, it would have the most significant impact on the actual size of the number. So that's my first significant figure. I look at that column and I need to round it to that column. That column's the tens column, so I round it to the nearest 10. 39 to the nearest 10 is 40. With this one, we want the first non-zero column. So in this case, it's this column. This column is the tenths column, so I need to round it to the nearest tenth. The nearest tenth here, it would round to is 0.9. Next question, 25% of 12, which is the same as 1/4 of 12, which is just £3. Right, 1% of 33 is just 33 divided by 100. 33 divided by 100 is 0.33 or 33 pence. So either £0.33 or 33p.